So some applications of our arithmetic and geometric series, and the first one we got here came from the 2007 HSC. Heather has decided to go swimming to improve her fitness level. Right, so the first day 750 metres, every day after that add another 100 metres, another couple of laps. And just to make sure you understand exactly what this problem means, that means next day 850 and the day after that 950. Write down a formula for the distance she swims on the nth day. First term 750, common difference is 100, a plus n minus 1d, subbing it all in, tidying it up, we have a formula. Okay, part 2. How far does she swim on the 10th day? Well, let's sub 10 into our lovely formula that we just worked out. 1,650 metres after 10 days. Quite an accomplished swimmer is Heather. What's the total distance then? In all those 10 days, how much did she swim all up? Well, sum to n formula, n over 2, 2a plus n minus 1d, subbing it, 12,000 metres. That's 12 kilometres. Of course, we could have used the a plus l formula because we know the last term, we just worked that out. It also comes up with the same answer. Something I'm sure we all would like to know. After how many days does the total distance she swam equal the width of the English Channel? A total of 34 kilometres. So our sum to n, we would like to know when is that equal to 34,000. We end up with a quadratic to solve. Well, actually everything divides by 100. What multiplies together to give negative 680? What adds together to give 14? We have our numbers 34 and negative 20. So it's either going to be negative 34 or 20. Now if she was smart, she would take the option negative 34. Because that would mean I'm going to start, but go, well actually 34 days ago, I'd already achieved it, so now I don't have to do anything. 20 days to swim 34 kilometres. A company's sales are declining by 6% every year, with 50,000 items sold in 2001, during which year will the sales fall below 20,000. This, of course, is a geometric. First term is 50,000. Our ratio, it's declining, so it'll be 0.94. We wish to know when is that general term less than 20,000. We have an exponential inequation to solve. Play around with it. Now, okay, at this stage we could guess and check, that's certainly a valid way. Or we could use our logs, log both sides. That allows us to bring the power out the front. Divide by the logs, the thing of course we have to be very careful with is when you divide by a log of a number that's smaller than 1, it's actually a negative number. And of course if you change the sign, you change the sign. We end up with, it's got to be greater than, during which year? So how do I answer it? Well, I've put both down. I've said, oh, during the 16th year, but then I've also named the year. That'll be 2016. Sales will fall below. Here's another HSC question. Anne and Kay, they're employed by an accounting firm, and they've come up with a very creative way of having their salary increases, this firm. For Anne, they said, how about this offer? And she accepts it. Initial salary, $50,000, and she'll just take an extra $2,500 every year. Kay went for a different option, also started with $50,000, but just says, I would like mine increased by 4% every year. Okay. So Anne is arithmetic, Kay is geometric. What is Anne's salary in her 13th year? Well, term n is a plus n minus 1d, so term 13, we can work it out. She will end up earning $80,000. What about Kay? Was she smart? Should she have gone for the other option? Let's see. Geometric, subbing into that one. Hey, $80,051.61. She's come out better by a massive $51.61. But let's say they went for 20 years. By what amount does the total amount that Kay gets in her first 20 years exceed what Anne gets in her first 20 years? They managed to last at this company for 20 years. So the total amount, Anne would end up putting into our sum to n formula with $1,475,000. Actually, it's not that unusual to earn $1 million in 20 years when you think about it. Kay, sub into hers, And, ooh, look at that, 1,488,000. Oh, she's done significantly better. Look at that, 13,000, almost $14,000 more. Looks like K was the smart one. Not really an application one, but I thought I'd throw it in here. It's an interesting sort of question they like, because the good old explain why. Explain why this does not have a limiting sum. Basically it comes down to knowing the definition. Well, we know it's only going to be when the ratio is in between -1 and 1. The ratio in this case, I've just left it as 1 on root 2. So okay, the ratio is 1 on the root 2 minus 1, which is about 2.414. So that's why it doesn't. R is bigger than 1. Then they asked this one in the HSC. Similar sort of question, but a lot harder. Here's the series, 1 minus tan squared theta plus tan to the power of 4 theta. When the limiting sum exists, so sometimes it will, sometimes it won't. All depends on the value of theta. So when it exists, find its value. Well, A is 1. Now when it exists, the ratio will be minus tan squared. Now, A over 1 minus R becomes 1 over 1 plus tan squared. They want it in its simplest form. 1 plus tan squared is sec squared, but the reciprocal of sec squared is cos squared. So the sum to infinity is cos squared theta. For what values of theta then does it actually exist? Again, it's got to be in between -1 and 1. So minus tan squared theta has to be in between -1 and 1, which means divide everything by -1. If you change the sign, you change the sign, but actually we've still got the tan squared theta is in between -1 and 1 and didn't change. Because whilst tan squared can't be negative, tan can be negative because you're going to square it. So yeah, it's all right for tan to be negative. Tan theta must go in between -1 and 1. You see what I mean? Remember, this is 2 unit. You can see lots of mistakes happening here. So when is that? That's what we're basically saying. When is theta in between plus or minus pi and 4? A lot easier, I think, with a graph to try and get your head around it. So we're trying to say, when is this in between? Well, yeah, okay. Right, it's in between those two values. Minus pi and 4 and pi and 4. So there's our solution. Theta is in between minus pi and 4 and pi and 4. It will have a limiting sum. Quite tricky for 2 unit. Quite tricky. So there's some questions on the applications of arithmetic and geometric.